Let's take a look now at example 3, part B and C. So again, we have all this information already entered into the calculator, but now we want to go ahead and create a histogram with 5 classes and a class width of 1. Well, notice here I can start to think about creating a frequency distribution like we did in the last section, where I can write down my different classes and their corresponding frequencies and kind of organize my data as such. Now I'm going to go ahead here and attempt to just state what my classes are if I want to have 5 classes with a width of 1. Now there are a couple different ways I can do this because I don't have a starting position specified, but it seems like here an easy way to get a class width of 1 would be to have numbers that go from, say, like 5 to 6. Well, almost 5 to 6. That would actually be a class width of 2, but maybe I could go from like 5 to 5.9. And since 5 here happens to be my lowest, or a value that starts with 5 is my lowest value here, maybe I'll make a class that goes from 5 to 5.9, then from 6 to 6.9, 7 to 7.9. I'll need one that goes from 8 to 8.9, and then I'll ultimately need one that goes from 9 to 9.9 to make sure that I can cover all the appropriate values in the table. Notice there are no values in here that start with a 10, so this should be sufficient. Now you can go through this table and actually count up how many items actually fall into each of the following categories. And I ask you to go ahead, pause the video, and see if you can try to do that really quickly. Okay, so if you actually did go ahead and do that, I got the frequencies of 1, 3, 12, 6, and 2. And so I could then go ahead and begin to sketch a histogram down below. Now, sketching out this histogram is again going to be fairly simplistic. All I'm going to be doing is drawing out a horizontal and a vertical axis, and I just need to create 5 bars because I have 5 classes. So 1, 2, 3, 4, 5. So you can see the bottom of 5 different bars shaping up here. And I can put kind of in each one of these 5 to 5.9, 6 to 6.9, 7 to 7.9, 8 to 8.9, 9 to 9.9. So I'm just labeling each of those. This is going to be a really rough sketch. Notice my largest group has 12, so I'm just going to go ahead and mark 12 right here. That would mean that 6 would be right here. That would mean that 3 would be right there. 9 would be right here. And everything else I'm just going to eyeball. So let's see, my first group has 1. So let's say that 1 exists about here. So there's my first bar. Then up to 3. Again, notice how kind of loosely I'm sketching this, right? I don't care about this being the most beautiful picture in the world. I just want it to be relatively accurate. Okay, so there's 12. Then I got to go to 6, so that's going to be like this. And then I'm going to have 2, which is going to look something like that. Okay. Now, I'm also told here to describe what the shape of this distribution would be. Again, there's some flexibility here in describing the shape, but I don't know. If you had to pick, what kind of shape might this seem to have? Well, I would think that a pretty good selection here would be that this is symmetrical, or you could say bell-shaped. Now, again, it's not perfect, but again, we had to work with some subjectivity when assigning these labels. So although it's not perfectly symmetrical, it's pretty symmetrical. Now, of course, and I guess this is extra space if you couldn't fit everything on that page, but of course, for part C then, I can easily see that, wow, once I know that this is a symmetrical or bell-shaped distribution, I could then think which of these 3 measures of central tendency might be the best to try to describe what's happening with this sample of babies. Would I use the average, the mean, the median, or the mode to actually go ahead and describe the data set? What would be the best measure of central tendency? And so again, what I'm always going to be thinking about there is the fact that when I have a symmetrical or bell-shaped distribution, I automatically, every single time, am going to select the mean as my preferred measure of central tendency. So my mean would be my selection here. If my distribution was skewed, then I would have definitely gone with the median. What you'll notice is kind of strange is that although the mode is always one of the options, it's actually never really going to be the one that we pick. The only time that the mode is really ever used is when we're dealing with qualitative data, where I don't have things that are numerical, and so that makes it very difficult to compute an average, right? Like, it's hard to compute an average favorite color of people, or to compute something, like a median favorite color. It just doesn't work, right? I mean, need numbers for that. So the mode is oftentimes only going to be used when we're dealing with qualitative data. Hopefully that gives you a sense of the types of questions that we're going to be dealing with here in this section of 2.2. And of course, you can go to the worksheet to practice some additional questions related to this content.